Good evening, everybody. Uh, Tonight, for the vBrownbag US podcast, we're going to learn about VMware Integrated OpenStack using NSX. Our presenter tonight is Nathan Ness at NVP Nathan on Twitter and I think as well on GitHub. Um, Nathan, if you just want to say hi, and I'll cover some of the housekeeping things.
Hi, everyone.
There's Nathan. So some quick notes. Remember, everybody's signing up for VMworld 2016. Remember that VM Underground and vBrownbag have an awesome event before VMworld, Tech Talks, and the VM Underground Party. Go ahead and check out those websites. Remember to get in on the conversation. The Twitter hashtag at hash vBrownbag. We're monitoring that. If you have any questions, if you are not able to use the presenter interface, you can go ahead and comment or shoot any questions through there. There's also our vBrownbag handles, not only for the US show, but for Latin, EMEA. We have an APAC one that I just forgot to put in there. And there's our schedule for our shows. Remember, we are a global organization. We have shows almost every week, sometimes every other week. Well, finally, I already introduced our guest. My name is Ariel Sanchez. That's my Twitter handle. I accept any and all feedback since this is my first time presenting, so be gentle. I'll now switch presenter over to Nathan.
Thanks, Ariel.
Sure. All right, I see you, and I'll make sure to mute myself.
Okay. Thanks a lot. So my name is Nathan Ness. I'm from the Networking and Security Business Unit at VMware. And today I'm going to talk about VMware Integrated OpenStack and NSX. I'm going to just run through a few slides to talk about kind of the solution, give you some context on what I'm going to show later. And then what I'd really like to do is spend a lot of time in like the demo environments and make this as interactive as possible. So with that, we'll go ahead and get started. So quick agenda here, we'll talk about, the contributions to the OpenStack community that VMware is making, the perception that VMware has to overcome inside the OpenStack community. We'll talk about some OpenStack use cases, what is VMware Integrated OpenStack, and then the NSX workflows inside of OpenStack, and then we'll jump over to some demos. Okay. So in the community, in VMware's involvement, we're typically in the top 10. We're not necessarily, first or second, but we always linger in the top 10 for contributions back to the community. And then this is for the Mataka release. Okay, so we do continue to contribute to the community all the way back to the Havana days, and so we are active inside the OpenStack community. So the perception that we have, and if you've probably heard this before in either a tech talk or something, but it's always like a versus, right? And that's the perception that VMware has to change, right? And what we have in reality is more of like, if you want to use VMware underneath OpenStack, that is perfectly supported, and we actually have our own distribution. A lot of people in even the VMware world don't necessarily know that we have our own OpenStack distribution, and we'll get into what that looks like. So what is OpenStack? So typically we have some application developers that have a series of tools, whether that be Git, Chef, Jenkins, or some type of CI/CD pipeline, or some type of automation tools for infrastructure or application development, and they want to use basic primitives of infrastructure, such as the compute, network, and storage. Right, and so when they see this from an OpenStack perspective, OpenStack provides that ecosystem for those tools, and it gives them a framework providing infrastructure APIs and gives them direct access to the infrastructure. Right, and so now we have an ecosystem of tools that the app developers can use, and then we give them that vendor-neutral API from OpenStack that can consume infrastructure underneath that. So this gives them the ability that they can provision, They can scale up and scale down. They can provide application and infrastructure updates. And this is some of the stuff that you'll see inside of the demo environment. And so when we look at use cases here, we want to, typically we see high churn environments such as dev, build, test, or CI/CD, which you may have heard of, which is continuous integration, continuous development, or continuous deployment. Repatriated VMs from a public cloud is a big use case. If you're using AWS today and you want to bring that back into a private cloud, OpenStack is a very valid alternative to that because it provides some of the same infrastructure primitives and the same or synonymous API calls that AWS uses. So what OpenStack isn't, and this is kind of what we see out in the community here, it's not a open source hypervisor, right? When I say that I'm going to use OpenStack as a hypervisor because it's free, well, OpenStack itself is not a hypervisor, and that's the same thing from a network and a storage platform, right? What OpenStack is just a framework to consume infrastructure. It gives them that vendor-neutral API for those third-party and development tool sets, right? And so it's architected as basically vendor-neutral and gives the customer choice from an infrastructure perspective, right? So inside this framework here from a Nova, Neutron, and Cinder perspective, and these are the different drivers that correlate to the compute, network, and storage underneath that, there's 3,000 different combinations of those drivers. Right, and so this becomes very complex when deciding on, choosing the different components underneath that. And when you're using vSphere as a hypervisor, this automatically kind of abstracts that because you're using the vCenter driver, which automatically abstracts your storage and your compute because that's actually now one driver. So I don't need to search for a specific driver for storage because if it shows up as a vSphere data store, I can consume that inside of my OpenStack cloud. Right, and so we provide a vCenter plugin inside of vCenter to consume that from a compute perspective, and this allows you to take advantage of some of those things like DRS and HA and some of the infrastructure primitives that are, build resiliency inside of the platform rather than having the, third platform where the resiliency is built into the application. Okay, so that's where we get into what is VMware Integrated OpenStack. So when we look at this, it is OpenStack. This is a distribution from OpenStack. It's called DEFCOR compliant. This is going to be DEFCOR compliant for Kilo. This is basically a set of tests that are ran to basically prove API compliance for the distribution to get the OpenStack logo stamped on your distribution. Right, so it's not a proprietary distribution. We don't VMwareize the distribution at all. We provide the same APIs that any other distribution would provide under the DEFCOR compliant logo. Okay. We pre-configure the drivers and plugins for VMware infrastructure technology. And what that means is we package this in an OVA, and when you deploy it inside of your infrastructure, you're basically run through a series of questions that you'll fill in IP addresses, port groups, you'll point to NSX, you'll add in some additional authentication information and hit finish. And this is something that I'm going to demo here shortly. But once that's done, it's going to actually pre-configure these drivers for your infrastructure. So it'll provision vCenter for the vSphere portion. It's going to configure NSX for the networking portion. And then it can consume any VMDK or any data store inside of that, whether that's VMFS, NFS, or vSAN. So any data store that shows up inside of your ESXi host, we can consume that for Cinder and glance volumes for storage. Okay. A lot of people don't know that it's free with any vSphere Enterprise Plus license. So if you have an Enterprise Plus license today, you'll see this in your My VMware portal. So you can go download this and test out the deployment. I'm going to show you the deployment here in a second, and then we can go from there. So a couple of things from an NSX component standpoint, because I will be showing VMware Integrated OpenStack with NSX, and so I just want to kind of quickly run through the models here from the different planes. So at the very bottom, we have the physical network. This is going to basically be our underlay or our transport for the logical networks that we are going to be creating inside of OpenStack. Next, we have the data plane services. You can consider this the ESXi hypervisors as the data plane, and then also the NSX edges, which is kind of our on and off ramp from physical to logical space. And these are also used as like Neutron routers, and you'll see this inside of the demo. So inside of the ESXi hypervisor, we install these kernel-level modules so we can get things like distributed logical routing, distributed firewall. So all of these things are actually happening at the hypervisor level rather than going out to the north-south core router or the north-south firewall. And we can basically provide these distributed services. And when we place this underneath OpenStack, OpenStack can take advantage of those. Okay? The control plane consists of 3 NSX controllers. In my environment, there'll be 1 just because of the limited resources. But in a production environment, you'll have 3 controllers, and they're all active, active, active. And they basically provide the control plane for what's happening inside of the data plane. Okay? The management plane, the manager, NSX manager, is our API endpoint. So when OpenStack makes Neutron calls, it's going to actually call NSX manager, which is going to push the configuration down into the different hypervisors. So whether that's going to be a logical switch or distributed firewall rules, that's going to actually go through NSX manager. Okay? And at the top we have OpenStack, and I'll be demoing VMware Integrated OpenStack, and we'll demo the deployment, and then we'll demo a 3-tier application deployment as well. Okay? So the network workflows within NSX. So we went over the different components, and so this is what I'm actually going to show inside of the demo. Okay? So inside of this, when I go into OpenStack, I'm going to create a web logical switch. I'm going to add 2 web VMs onto that. And to note, all the VMs are completely blank. So I'm actually going to use Cloud Init inside of OpenStack to pull their configuration and give the VM their identity. So all of these images are going to be used with the default Ubuntu image that comes with VIO. And then I'm going to use Cloud Init and some scripts to actually give them the identity through the heat template. And all this heat template is on my GitHub. So if you want to go to MVP Nathan, you can download this heat template that I'm going to be demoing here shortly. Next, I'll provision an app logical switch. Again, I'm going to do this as the app tier. This is actually going to install WordPress. My web tier is an Nginx, so Nginx is going to act as a reverse proxy. Then I'm going to install a database network, which is going to install a VM there, and it's going to install MySQL. Okay. On top of that, after those networks are provisioned, we have layer 2 connectivity between the different tiers, but we have no layer 3. We're also going to create security groups on the fly as well. So I'm going to create a database security group, an app security group, and a web security group so they can all talk to each other and provide that micro-segmentation between the different tiers. I could provision this all on one flat network and provide the same micro-segmentation. Just because I'm using the distributed firewall, we don't care if it's on a different segment or not. It could be provisioned all on the same network and it act just the same. Obviously, I'm going to need L3 connectivity between this, so I'm going to provision a Neutron router. This is going to give me, not only connectivity between the different tiers, but it's also going to give me external connectivity so I can actually access the application and also test my application as well. Okay. Then I'm going to assign a floating IP for the load balancer. So this is going to be using what's called load balancing as a service through NSX and VMware Integrated OpenStack. So it will provision a load balancer, and it's going to load balance between Web 1 and Web 2. Okay. One more slide here on just the security groups, because this is pretty important. So when we look at security groups inside of Neutron and inside of Horizon here, this is just a screenshot of Horizon OpenStack. These get translated into distributed firewall rules inside the NSX distributed firewall. Okay, so we provide that isolation, the microsegmentation. OpenStack is natively multi-tenant, and we provide that with the NSX distributed firewall. So you do get the stateful firewall if you're using NSX with OpenStack. Okay, so those are all the slides I have. And then the rest of the time we'll spend doing some demos here. So if there's any questions, please let me know.
Yep. Let me see. I do actually see a question.
Okay.
It's from Graham Mitchell. It says, how much of all this is part of the Enterprise Plus licensing?
So VMware Integrated OpenStack, the distribution will be included. If you have a vSphere Enterprise Plus license, we don't charge anything for VMware Integrated OpenStack as a distribution. We do charge for support. So if you want support for your OpenStack distribution, it's $200 a CPU.
All right.
Okay. And then NSX would be purchased separately. Obviously, that doesn't come with the Enterprise Plus license.
Okay.
Okay.
All right.
All right.
And I see a couple. Let's see. Everything in the slide below, OpenStack in the slide, is a separate product. Okay. Thanks. So I think Graham got answered. But basically, you do have to have NSX. Support may be extra, but the actual VIO is included with the licensing.
That's correct.
Awesome. And I have to thank you because this explanation has been very enlightening. So looking forward to the demo.
Okay. So hopefully everyone can see the web client. Ariel, can you see the web client?
Yes, sir.
Okay, good. So what I'm going to walk through now is kind of the prereqs if you were to go download this and install it. So there's a couple of different things that'll make your life a lot easier, and if you just pay attention here, you'll understand kind of the prereqs on how to set it up, and it'll make the deployment a lot easier. Okay. So here I'm going to deploy with NSX, and this is going to be, if you were to go onto my VMware, this is that vApp that you will download. So if you were to download the OVA, you're going to deploy it in what's called a management cluster, and this management cluster will consist of 3 hypervisors. The reason for this is we deploy a completely scaled out production ready OpenStack, so there'll be 3 database servers, 2 controllers, so on and so forth, and it's actually going to create anti-affinity rules inside of your vSphere cluster so that the 3 database servers can, never live on the same host. So if a host dies, obviously you're not going to lose 3 database servers or so on and so forth, or 2 controllers. So we try to make it as highly available and as resilient as possible. The second piece to the 3 hosts is we also require 3 data stores for that as well, because the 3 database servers will not only go on to 3 different hypervisors, but they'll go on to 3 different data stores. Okay, so inside your management cluster, you'll have 3 hosts with 3 shared data stores. Once you install the VMware Integrated OpenStack vApp and turn it on, you're going to go into the web client and you're going to see a new icon appear called VMware Integrated OpenStack. Okay, so I'm going to quickly run through I think it's important to run through the NSX prerequisites, and then we'll jump into the deployment. So here I've actually deployed NSX Manager and linked it to my vCenter here. And then it becomes very simple to, from a prereq perspective for this, because we actually deploy this. And say we only go up to a certain point, which is installing the transport zone, right? So I have 1 controller here, and again, I should have 3 controllers here in a production environment. I have my NSX Manager. My host preparation will be compute cluster and edge cluster. Those will need to be prepped. And then my logical network preparation, I'll need my a transport zone installed, okay? And then I'll have a segment ID, which is going to say, this is basically just VLAN IDs, which will be 5000 through 5099. It can be any type of segment IDs for the consumption of the Neutron networks. And that's all you'll need to need set up for your VMware Integrated OpenStack, because you actually select the transport zone during the deployment, okay? So once you have that icon, you power on your vApp, you'll have the icon, you'll click on it, and you'll see a basic task called Deploy OpenStack. So once you click on that, you're going to run through a 13-step wizard, and this is going to, again, ask you that series of questions, and at the end, you're going to click Finish, and it's going to kick off the deployment. Okay? So I'm just going to load a template here so you don't have to watch me type in a bunch of IPs. So the first thing is you're going to name the deployment. You can name it whatever you'd like, and then you're going to put in the vCenter where you deployed the OpenStack management server, and then authenticate to that. So I'm going to authenticate to the vCenter. If you have a valid certificate, you don't have to hit ignore, but it will try to validate the certificate. Okay? So the first question it's going to ask you is, where do you want your OpenStack control plane? And in this particular case, obviously, you're going to want your OpenStack control plane in the management cluster. This is where those 3 hosts are going to reside, the 3 data stores. And so you'll just click the checkbox there of where you want the control plane to land. Click Next. Next, you'll select the different networks for the control plane. So this is actually where that control plane is going to land. So the first one is going to be the management network. I think everyone's fairly familiar with this, but if you're not, you can click on these little eyes here. It'll give you a little bit of information of what this network is for. And then you can also click on the eyes over here and say how many IPs are required. And this does need to be a contiguous range, right? So I'm going from 170 to 189, and a minimum of 18 IP addresses are required for this. So this is going to be the IPs for the different control plane components, like the database servers and the controllers and memcache and message queue. Subnet, gateway, DNS, that's all pretty self-explanatory. The next network is my API network. So we deploy 2 load balancers as well. So we load balance both external users and internal services. So if the 2 controllers, we load balance those, 3 database servers, so on and so forth. So this is going to be for the external version of this, where you can say, I only need 2 IPs here, because these are the 2 load balancer IPs. So you only need 2 IPs for the API network, because they're actually going to be for the load balancer's IP address. And then subnet, gateway, DNS, again, that's self-explanatory. What this is going to do is validate your IPAM solution. Hopefully it's not an Excel spreadsheet, so if you have any IPs that are in use already, it will check that. So it's essentially going to do an nmap on every single one of those IPs that you typed in. It also does a reverse lookup on this host name. So if I change this to something incorrect and try and hit next, it's going to error out and say 192.168.0.100 does not resolve to vio.corp.local. Right, so I'll just correct that again. So again, it's the deployment's trying to make it as as successful as possible here when you're deploying this. So it'll validate here. It'll be a success this time. The next thing I need to add is my next Nova compute cluster. So this is going to actually be, for those that aren't familiar with OpenStack, this is actually where tenants are going to actually place instances. So when a tenant logs into OpenStack and deploys a VM, it's going to land in this compute cluster. So you'll need your first compute cluster deployed at the time of deployment of OpenStack. So here I'm just going to add Nova cluster. I'm going to say compute cluster 1 and say next. Nova data stores. So like I said in the presentation, so any data store that shows up here, I'm using NFS. But if there is, VMFS or vSAN here, I could select those data stores as well. And again, this is just a checkbox. So if it shows up as a data store, you're allowed to select it. If you only want to do one at this time, I could select another one as a day 2 item, and it will actually automatically deploy it, restart the appropriate services for you, change the comp file. So it's really nice and from a day 2 perspective as well. Glance data stores is the same thing. I'm just going to add my glance data stores. This is where my OpenStack images are going to be stored. Okay, so I will select the first one because VIO does come with a default Ubuntu 14.04 image, and this is where it will land here on NFS 01. So I will select my first glance data store as well. Networking, to answer the person's question on the phone, there is actually 2 modes for networking. You can use the virtual distributed switch. It's very limited. Basically, that slide of network workflows, none of those will work because those are all done through NSX through dynamic provisioning, right? So you can use what's called provider-backed VLANs with the VDS, but it's mainly meant for very small like POCs or just testing out the deployment. We don't have a lot of deployments with using VDS because it's so limited. So here I'll authenticate to NSX Manager. And then I'm going to select that transport zone that I showed you prior. Okay? And then I'm going to select my edge cluster. And this is one of the clusters that you saw in vCenter. This is where actually it's going to pre-populate a bunch of NSX edges for consumption for Neutron routers. And you'll see that in the next environment here. And then I can select the virtual distributed switch and my first external network. And I can click Next. So we support both Active Directory and the internal Keystone database here. So if you want to choose Active Directory as an authentication mechanism for OpenStack, you're certainly allowed to, and you can use SSL or non-SSL. For time purposes, I'm just going to use local Keystone. Configure a syslog server. You really can't operationalize OpenStack without one. The amount of logs that OpenStack spits out, and I'll show that in the next environment here. So here you'll actually point to your syslog server. This can be Splunk. This can be Log Insight. In this environment, it will be Log Insight. and we do have a content pack for it, which I'll show you here. And so this will be validated as well. Customer experience program, and see this loading screen here. This is actually checking the management cluster for a couple of things. So when you get to this point, this is where you'll know whether you're successful in your prereqs, because it's checking to see if you have 3 hosts, if you have 3 data stores, again, if you have vMotion enabled on the cluster. So it checks all those things to make sure that you have the management cluster set up properly. And if the loading screen goes away, you can hit finish, and it will start deploying the OpenStack deployment. Okay, so this takes about anywhere from 30 to 45 minutes, depending on the speed of your storage. Okay, so you'll see a little progress bar here. It'll go from 1 to obviously 100, and then it'll say running. So if we look at our vSphere environment now, you can see that it's quite changed, and there's lots of stuff going on here. So it's now created this resource pool with the control plane, and it's going to actually deploy each one of those VMs, such as the compute node, the controller, the databases, the load balancer, memcache, object store, and the message queue. And so once those are all powered on, it will run through a series of playbooks and give the compute driver its identity, controller its identity, through the OpenStack template. Okay? So this is the function of this OpenStack template, because this is the template that gets cloned for the control plane. All right? So this does not need to be powered on. Even if you just power on the vApp, the OpenStack template will never be powered on. So think of the management server as like the vCenter for your VMware Integrated OpenStack control plane, right? So this will do all of your day 2 items, and I'll show you some of those in the next environment. We're not going to wait for this to deploy. Again, this takes around anywhere from 30 to 45 minutes, depending on the speed of your storage. So just let this go through. Once it's done, you can actually open up a new tab and go to the URL that you type in or the IP that you use for the VIP, and you'll be prompted for a login for Horizon. So that's what we'll show in the next environment. Okay? So I'll pause there for questions before we move on to the next one. Any questions?
I don't see any questions on the tweeters or in here, but I do have one question from me, just because I'm very, very new at this. Is there any requirement on OpenStack component versions for it to work with VIO, or you basically most are okay?
That's a good question. So are you talking like for vSphere versions?
Yeah, but also I saw that it asks about some particular OpenStack components in the installer walkthrough, so I was wondering.
Yeah, that's a good question. So from a vSphere perspective, we do support 5.5 U3, vSphere 6, 6.0. I believe our stack is 6.0 U2, but we do support 5.5, and then NSX would be on 6.2.2. And then from a OpenStack perspective, today the distribution is based upon Kilo. So when you deploy VMware Integrated OpenStack, today you're gonna deploy Kilo.
Awesome. Thank you so much.
Yep. Okay. So here I'm actually going to show a couple of different things. So let's see, how much time do we have? I'm going to kick off a deployment here real quick, actually. So I'm going to log into my home lab environment here. Can everyone see me logging into OpenStack?
Yes.
Okay. So what I'm going to do, I'm going to show you kind of this blank canvas, right? So OpenStack is kind of a different consumption method where as a developer or as a member, there's basically 2 roles in OpenStack. There's member and admin, and I'm logged in as a member right now. And so as you can see, this is kind of the network topology screen. It shows you what you have deployed, and I've deployed nothing in this environment here. So what I'm going to do is kick off a heat template from my GitHub account, and it's going to deploy that 3-tiered application that I showed you in the slide deck, right? And so this is kind of that blank canvas. So as a member or as a developer, I basically have direct access to infrastructure based upon a set of quotas. So if I look at my quotas here under Overview, this is basically what I can consume. So I can have 20 instances, 40 vCPUs, 50 gigs of RAM, but the key thing here to remember is I can deploy this however I would like to deploy it, right? I can change it up in any cookie cutter fashion. It's kind of like a buffet style for infrastructure. So it's a little bit different consumption model than other cloud management platforms, where typically maybe you have, like, you'll log into a self-service portal, you'll see a blueprint there, and you can deploy that blueprint. In OpenStack, I have like carte blanche access to the infrastructure, and I can deploy it in any rhyme or reason that I would like, right? So if I go over to orchestration and stacks, this is actually going to use what's called Heat, and Heat is the orchestration engine for OpenStack. And what I'm going to do is I'm just going to grab this URL off of my GitHub, and this is going to be that Heat template that I've built that's going to deploy the compute, network storage, security groups, give the VMs their identity. Like I said, I'm going to use just the default image that VIO comes with. So I'll say launch stack here, and then I can point to a file. So if I had this YAML file saved on my desktop or somewhere local, I could easily point to a file. I could actually paste the entire contents of that inside of this. But I like to just use the URL, and I'll just paste in the GitHub URL, and that will pull the URL off of GitHub, and then it's just going to ask me a series of questions that I've defined as parameters inside of my Heat template. So I'm just going to name this vBrownbag WordPress. I'm going to authenticate my user for Heat. And then my application image, this is going to be my app image. So this is going to be for the WordPress VM that gets deployed. And this Ubuntu 14.04 server AMD 64, that is the default image that comes with VIO, right? And so here's where I can actually name my database, right? So I'll just name the database vBrownbag. And so this is actually going to give when it deploys the MySQL server, it's going to actually give this database name to the MySQL server for WordPress. And then I'm going to use the database password. I'm going to set the database user, database image, my external network, which is that blue line that you saw on the network topology screen. And then I can also set the MySQL root password. And then lastly, I'm going to select the web image, which is already set as the default image as well. Once these values and questions have been answered, you can hit Launch Stack. This is actually going to launch the stack and provision all of this infrastructure inside of my OpenStack environment on top of vSphere. So here, if we look at this after it's launched, and I go back to my network topology screen, you can see that it's going to be very, very different, because it's going to start provisioning networks, it's going to start provisioning routers inside of OpenStack, so on and so forth. So once we see this start provisioning here, we'll just give this some time. While this is provisioning, I'm going to go ahead and log back into an environment where it is deployed and kind of show you some different things that are available within inside of OpenStack. So there's the web network, the app network. It will deploy the DB network here shortly. And then also it'll assign subnets. Once the infrastructure pieces are set up, it will actually create the rule set for it. So the application security group, web security group, DB security group. Then it will deploy the VMs, and it will grab its identity off of Cloud Init. Okay? So we'll let that run for just a little bit. That takes about 8 minutes, start to finish, to actually wire all this up, pull all the packages down, give everything its identity, configure the load balancer, which is pretty good considering in a typical environment. I mean, this may take 3 to 4 days or 3 to 4 weeks, or who knows how long, right? So this is in 8 minutes. You have compute, network storage, and an application on top of a blank VM. It's not a bad timeline. But while that's deploying here, I want to kick off to one of the other environments where I have the exact same template deployed, and kind of show you some different operational tools if you're familiar with vRealize operations or log insights, right? So here, if we look at the network topology screen, you can see that it's completely deployed, where I have the web VMs and app VMs across my environment. So my home lab will look like that here shortly, but this is a completed environment here where I have 2 web servers, a database server, and then an app server. Okay. So what's pretty neat about this is not only that's deployed on vSphere, we get to take advantage of things like DRS and HA for these different components inside of this. So here we can see our compute cluster now, where we have the app DB and web server provisioned inside of our vSphere environment. We also see this from a NSX perspective as well. Okay. So if we go into, for instance, the distributed firewall, we can see these firewall rules that were being dynamically created and the rule sets that are going to be dynamically created. Okay. Just wait for this to come up.
Yeah, gotta say, I'm really loving all that integration and how it, being a vSphere administrator, the level of automation and scripting, and you basically had a text file that said do this, and it just went out and did it. It's pretty awesome.
That's the power of heat, and to be honest, I mean, you should be able to point that heat template at any OpenStack environment. That's kind of the cool thing about OpenStack as well, where again, this is the vendor neutral API. You can build heat templates in JSON or YAML. Mine is built in YAML because I'm always missing a parenthesis in JSON. So, I mean, it just runs through a very, typical resources where it's creating a web network, creating a web subnet, and then it just does all those references here. So, but it's very powerful, heat is, and it, integrates very well with vSphere when you're using it. But so back to the firewall rule set. So here's these database security group. Let's just take this one for an example, and then we'll move on. So I'm creating a database security group. If we click on this, you can see that my database instance was added to this, right? And so this was all dynamically created through heat as well. But here's kind of the interesting pieces where I can say, for my source and destination, like everything is allowed out for my database server to go grab packages like MySQL. I could lock it down if I wanted to and really provide that true microsegmentation or even zero trust. But here I'm allowed nothing back in except for the app tier. So now I can say my app instance is only allowed to talk to my database server over 3306, right? So I'm providing that microsegmentation from not everyone can get to my database server. In fact, the only thing that can get to the database server in this case is the app instance over MySQL, right? Same thing with the web tier, right? So only the web tier can talk to the application tier. So we're providing that microsegmentation within OpenStack through heat. The next piece that I wanted to kind of touch on is, it's one thing to deploy OpenStack, and then it's another thing to operationalize it. So what we have here is I'm actually monitoring the entire control plane through vRealize operations. So I can actually see if my OpenStack control plane services are going down. For instance, if Nova Compute was down, I would see this turn red. Right, so I can see that my Nova Compute service is healthy from health, risk, and efficiency, if anyone's familiar with VROps or VCOPs, as it used to be called. But again, it's kind of the true power of saying, all right, if my VM doesn't deploy, where do I go look? So this kind of gives you a global view of how your OpenStack control plane is behaving. And you can do the same thing from a network services perspective, storage as well. And this is all done through a management pack for OpenStack, and you just add that into VROps, pointed at your VMware Integrated OpenStack deployment, and you can see these type of details. The next ones are, you can see like from an OpenStack compute infrastructure, it's actually monitoring the Nova Compute cluster, so it gives you a narrowed down view of actually what is only related to OpenStack. So for instance, if you had a vCenter with, numerous clusters in there, I only want to see what's relevant to OpenStack, and that's what this is doing. You'll see, compute cluster 1, which is monitoring my 2 hypervisors inside of that compute cluster, and I can see that I've, 0 issues inside of that. It is monitoring NSX as well. So here you can see that the controller here, if we click on this, it's got a warning. So you can see that my controller resource usage is high. So again, this is kind of a scaled down environment where I can say, hey, but it gives you a very high level dashboard of what's happening inside my cloud environment. So it gives you that compute network storage point of view. The next one I want to show you is the object path. And this is from an NSX point of view where I say, I want to see the end-to-end connectivity between 2 VMs that are deployed inside of my heat stack. So I want to find 2 VMs that are on different hypervisors so it doesn't just show me. So my web and app. Okay, so let's do web and app. Those two are on different hypervisors. So let's just do an object path between them. So here, if we just look at web and do web instance 01. So if I click on that, then I can just click on app, and that will go to my second instance, and I can click on app instance 01. What this will show me is kind of the end-to-end view, not only from a logical perspective, but from a physical perspective as well. So if I had SNMP inside of this, this would show me the end-to-end between the two hypervisors and also my physical network, right? So this becomes, and then also the health in between that. So I can see that this this web instance is powered on, that one's healthy, my logical switch that was powered on or that was created is healthy as well. Here's the application router. A lot of these are false positives, so if you see orange here from a risk perspective, OpenStack doesn't necessarily turn on a lot of features. NSX has lots of features, but Neutron is, you know, kind of the basic L2, L3 load balancing. So it doesn't have HA turned on, so that's going to be an alert there as well. So this is meant for, like, if this is in production, hey, you should probably turn HA on. But OpenStack environments are typically torn up and torn down relatively quickly. If we move on to the next one here, you can actually see the OpenStack tenants dashboard. And this is, you can actually see from a tenant perspective what they've deployed. So if I'm a vSphere admin and I want to see what project one's deployed and is being used from a quota perspective, here I can see that three-tiered application as well from a high-level view. So I can see that they have used 40% of their quota for instances. They've used 20% of their vCPUs, and they've used 16% for their RAM that's allocated to them. And then here I can see, again, the web instances here. If I want to expand this node, I can go ahead and expand it and say, hey, what NSX edge is this connected to, and see the router that it's connected, and see the health of that as well. So it becomes very powerful, and the more projects I have inside of OpenStack, you'll see the different projects inside of that, and it kind of gives you that bird's eye view of what's happening within that project. Okay? Any questions here?
It has to be really handy when you have a bunch of clients, right? It's pretty cool. Let me.
Yeah.
Go ahead.
Yeah, this is probably one of my favorite dashboards here because it can quickly narrow down. You can just ask them, hey, you know, what project are you a part of? I'm project 1. And you can just go inside of this and say, all right, let's click on project 1 and see what's happening inside of the environment. So yeah, very, very powerful from a visibility perspective and, you know, finding that needle in a haystack. Okay?
Yep. No questions. Go ahead.
Okay. So Log Insight is the last component there. So Log Insight is basically a syslog aggregator, where we can say, you know, pump all the logs from VMware Integrated OpenStack, and it gives you this kind of this nice view of what's happening from the different projects. So here you can actually narrow down if I don't want to see any debug logs, you can just click on that, or info logs, I can click on that as well. And then this gives me kind of the narrowed down view of the different projects. If I don't want to see Neutron or Cinder, glance logs, right, I can just narrow down to what's happening within Nova, for instance. And here I can say, all right, let's see what's happening within Nova. I can go ahead and say, go to Interactive Analytics, and it's actually going to spit out that log data that's now associated with that, okay? And so this is actually going to say, you know, what logs were associated. Obviously, there's not very many here, but, you know, it gives you a good troubleshooting view, and it also gives you a point of view where you can actually narrow down to the different projects within OpenStack and count the logs as well that's happening between them. So I can actually go down to Keystone and see what's happening within Keystone or Nova, and kind of just drill down inside of that and say, all right, what's going on inside of my OpenStack environment? Okay. The last thing from a day 2 perspective, we do a lot of day 2 things. Like I said, that management server that we deploy, you can do a lot of different things from a day 2 perspective inside the web client, like update the syslog server that you're going to point to. If I've deployed a different syslog server, I can come in here and it'll point, and it'll actually go into every single control plane VM and automatically change it, restart our syslog for you. You can change the passwords of NSX and vCenter. You can deploy Ceilometer. Networks, this is going to be used for upgrades, which we'll get to here in a second. Nova Compute, if I add, let's say, Compute Cluster 2 inside my environment, and I want to add that into my OpenStack environment, It's literally just a plus sign and a next finish exercise. This will actually deploy a new Nova Compute VM that manages that cluster. If those of you familiar with OpenStack, typically there's Nova Compute that runs on every single hypervisor. In a vSphere environment, there's one Nova Compute VM that controls the entire cluster. So if I were to log in as an admin inside of OpenStack, you'll see one Nova Compute and one big hypervisor, even though I have two hypervisors inside of that. What that allows us to do is actually take advantage of maintenance mode inside of vSphere, where I can shut down or migrate live VMs off of the different hypervisors, upgrade them, patch them, do rolling upgrades. That's certainly all possible without taking any downtime from my tenants, which is, obviously important. Okay. Nova Storage, if you want to add more Nova Storage for your instances, again, it's just a plus sign. You'll add it into ESXi. Again, we support VMFS, NFS, and vSAN, and you can add that into the appropriate compute driver. Same thing with Glance storage. If you're running out of image stores, you can add another data store in for that as well. The same process applies. So updates, we support updates. You can think of VIO as an appliance from VMware. We provide patches, security patches. We patch the control plane. But bigger than that, we actually provide upgrades as well. So we can actually upgrade from, for instance, we're on VIO 2.0, but we do support an upgrade from VIO 1.0 to 2.0, which is a feat in itself. If anyone's read up on OpenStack upgrades, they're very much a challenge. So we do support in-place upgrades. We use the blue-green method for upgrading the OpenStack control plane. We will provide a migration. You can do rollbacks pretty much any time during the upgrade process, but we do support upgrades for OpenStack. And then lastly, we support Horizon regions. If you're linking to VMware Integrated OpenStack control planes together for different regions, it'll do a Horizon change where you can actually log into either region that you've selected. Okay, so lots of day 2 items that you can do as well. And any questions there from an OpenStack perspective from day 2?
We actually do have a question. And this probably applies to any vSphere supported storage. Graham Mitchell asks, are vVols supported for storage?
Yeah, so that's a good question. So vVols, I believe, are going to be in the next version for VMware Integrated OpenStack.
Awesome.
Okay. Any others?
Nope. It does seem that he says thanks, but no.
Okay. All right. So I'm just going to make a quick change here. So this looks done. If we go to, this is back to my home lab. If people are getting confused on how many demo environments I have, but I thought it'd be good to kind of show as much as possible in an hour session. So this is that demo environment that I left to show you some of the day 2 operations tools. So here you can see it's complete, but now I want to actually see what happens during that. So here is all of the different components inside of my heap template, but I want to go to overview. And why I want to go to overview is because I want to see the different outputs. And so here I'm actually going to go to my outputs are the vibrownbag.ddns.net and then 71254 here. So just give me 1 second. And I'm going to try and so here I'm just going to go ahead and go to this IP because I don't want to waste any more time because we only have a couple of minutes left. But typically what I do is I open up my firewall to that 71254 and change it. But I'm just going to go to this the NSX load balancer IP. That's the other output I have. And so I'm going to open up a new tab here and click on that or go to that, and it's going to send me to that WordPress URL. So here I can just type in vBrownbag as my site title, say admin here, and install WordPress. Okay. So now, we have a running WordPress installation. Again, this can be, this is an example of just deploying a 3-tier application from scratch, from compute, network, and storage. But it really shows you the power of orchestration and the power of using APIs and application templates to deploy infrastructure, right? And again, what I ask you guys to do is like, well, how long does this take in your environments to deploy this compute, network, storage, security groups? If we want to look at the security groups, we can go to Access and Security and say these database security groups, web security groups that I showed you in the distributed firewall, these are all going to be, these were all dynamically created within the heat template. So again, if anyone wants the heat template, it is on my GitHub. So there's several other heat templates as well. So if you want to go there, check them out. You can test them out, use them, deploy VIO, and use them in your own VIO deployment.
That's pretty cool.
That's all I have, Ariel.
Yeah, no, it's amazing how much is included in the heat template, because it even goes into the VMs and sets up, the databases and all these passwords. And we saw it live here that a new WordPress site came up. That's awesome. So go ahead.
Oh, I was just going to say I really appreciate everyone's time and participation in here. And if anyone has any questions, just please reach out to me at Ness@VMware or on Twitter at MVPNathan.
Awesome. I do have one question from Graham, and it's probably just a general NSX question. He says, how good are the NSX load balancing services compared to something like an F5? And this is a wide question, so feel free not to answer it in depth.
No. It's a good question. So underneath Neutron, in this instance here, we support everything that Neutron supports in this. This is LBAS version 1 from Neutron. So the NSX load balancer supports everything that the Neutron spec supports, right? So, but let's just say we're not using OpenStack for a second, and we're just using vanilla NSX. It does support a lot more sitting outside of that context, but it is certainly not like the Cadillac of F5 or, if I have, let's say, an application with a bunch of iRules, that's probably not going to be a good fit for an NSX load balancer, right? We do support application rule sets in a limited fashion, not obviously to the extent of F5. So, it really depends on the use case, I guess would be the question. The best thing to do would be to get with your NSX SE and say, all right, here's my use case, here's my application, this is what I'm doing today. Would the NSX load balancer be good with that, or they'll tell you yay, nay, based upon the application.
Yep. All right. Well, I think we've all learned a lot. I really appreciate your time. The presentation was excellent. We're getting a lot of very positive comments. We really appreciate it. In case you want to give out any other contact information for your Twitter or your GitHub, but I think we're done.
Yeah, no, just MVP Nathan, and the GitHub is MVP Nathan as well. So go test out those heat templates and let me know how it goes.
Excellent. I'll start the recording right now. Thank you so much, and thank you for everybody that attended.
Thank you.
Thanks, Nathan.